Hey, hello everyone. Welcome back to our channel Physics, where we actually learn physics. So in our previous lecture, we have talked about what are significant figures, right? Okay, we have actually discussed in details what is the importance of significant figures, okay, and what exactly do we mean by significant figures, and not only that, how exactly do we represent any measured quantity, right? Okay, and what is the relation between this way of writing the measured quantity and the significant figures, and what is the relevance and what is the relation between the precision of the instrument and the significant figures. So all these things we have talked about in the previous lecture. So if you have not seen that, please go and check, because that video is going to be important to understand this video. Okay, in fact, even if you don't see that, that is going to be still okay, but if you see that, that would be much beneficial for you to understand what are significant figures. Over here in this lecture, we are gonna find out, or we are gonna study some rules, okay, some rules to find out significant figures, okay, or significant digits. So in any measured quantity or in any number, okay, in any number, what are the number of significant figures, okay, or which exactly are the significant digits in a particular given number? Like, you can see some examples I have written over here. So out of these digits, okay, in this whole number, which are the significant digits? How to find out that? Okay, so for that there are some rules, and those rules will be studied over here in this lecture. Okay, so we will understand each and every rule with these examples. Okay, so as we go on with those rules, okay, at the same time we will solve these problems over here. We will find out which are the significant and which are the insignificant, okay, or non-significant digits. So I have written, you can see here, significant digits and non-significant digits. So what we will do is, we will see rules, and after the end of the rule, okay, we will find out, by using that rule, we will find out which are the significant digits in this number, which are the insignificant or non-significant digits in this number. In that way, for all those numbers, we will do the same thing, so that immediately we will understand the rule, okay, very quickly. So let's start and let's see what are those rules. Okay, so first thing that you need to remember, okay, first thing that you need to remember over here, that significant figures talk about the precision of the instrument. Okay, significant figures talk about the precision of the instrument. So, any value that is given here, okay, any value that is given here, first check that are those digits, okay, are those digits in the number talking about the precision of the instrument or not. Okay, if that digit, okay, if the given digit is talking about the precision of the instrument, then that digit is definitely significant. Okay, if any digit out of this is talking about the precision of the instrument, okay, then it is significant. So all the rules that I am going to talk about, they are based on the same criteria. Okay, what I said is not a rule, actually it's we can say a common understanding about significant figures. Okay, so now let's see what are those rules. Okay, so the first rule says that, okay, first rule says that all the non-zero digits are significant. It's very simple. Okay, all the non-zero digits, okay, digits which are not zero, they are all significant. Okay, they are all significant. So over here I can check this 2, this 1, this 3, they are non-zero, so they are significant. So you can just write here 2, okay, then 1, then 1, then 3, okay, they are significant. Now what about these zeros? According to our rule, okay, all the non-zero digits are significant. So we have written the non-zero digits over here. Now what about the zero? So for those zeros also there are some rules which we are gonna see. Okay, so right now we are not gonna talk about these zeros. Okay, but there are rules. Then we will talk about those zeros also. Now over here, which are the non-zero? 5, 6, 3. So 5, 6, 3. They are definitely what? Significant. Okay, they are definitely significant. Now here 9, 1, 1. So it's 9, 1, 1. So these are significant. Over here 1, 3, 1. Okay, these three are significant. Here 2, 3. Okay, 2, 3. They are significant. See, these zeros are also there, but we have not yet talked about the rule regarding zero. So once we talk about that, then we will check, okay, about those zeros also. Okay, now here 5, okay, 5 is the significant, it's non-zero. 6, 1, okay, then 5, 1, 2, okay, 5, 1, 2. Okay, so right now we have these many significant digits according to the first rule. So the first rule says that all the non-zero digits are significant. Now all the non-zero digits are done with. Now we will move to the zeros. Okay, what about the zeros? Now actually the zeros that appear, okay, zeros that appear in any number, they appear in actually 3 ways. Okay, they appear in 3 ways. See here, you can see here there are some numbers with decimal point and there are some numbers without decimal point, like here. Okay, here. Okay, there are some numbers with decimal point and there are some numbers with no decimal. You can check here. Okay, so over here zeros appear, okay, all these zeros, they appear in different ways over here. Like you can see over here, zeros, you can see, may appear between 2 non-zero digits. Here you can see these zeros are appearing between non-zero digits, and at the same time the zeros may appear at the end, not between the 2 non-zero digits. Okay, zeros may appear between 2 non-zero digits or maybe at the end. So these zeros at the end, they are called as the trailing zeros. They are called as the trailing zeros. So I would just write here. So, and these are the zeros between 2 non-zero digits. Okay, here also you can see these zeros are between the non-zero. This zero is also between the non-zero digits. Same here, this one. Then yeah, these two you can see they are between the 2 non-zero. Here, this one, they are also in between the 2 non-zero digits. Here also 0, this 0, okay, that is also in between the 2 non-zero digits. Okay, so zeros appear in different ways, like they can be trailing zeros, that is at the end, or they may be in between the 2 non-zero digits. But there is another way. You can see that some zeros appear, okay, at the beginning, okay, or you can say leading zero, okay, just before the decimal point. Okay, some zeros may appear before the decimal point. Okay, or in fact we can say other way. Over here you can look at this, these zeros, look at these zeros, they are appearing at the right. Okay, they are appearing at the right of the decimal point and to the left of the first non-zero digit. You can see here this one is a first non-zero digit. Okay, so you can see here there are quite a few ways in which the zeros may appear. So we have to talk about each one of those. Okay, and we have to have some rule for each one of the ways in which zeros appear. Okay, so now let's see the rules regarding zeros. Okay, how to find out the significant figures, whether these zeros are significant or not, that depends on their position. Okay, and how exactly they exist actually. So now first rule is very simple, all the non-zero digits are significant. Now we move to the second one. The second rule says that all the zeros, okay, all the zeros between two non-zero digits are significant. Okay, all the zeros between two non-zero digits are significant. So let's see over here. You can see this 0. This is between two non-zero digits. Okay, you can see this one. This is again between two non-zero digits. So these two are significant, isn't it? So we can write here 0 and 0. Okay. Okay, so these are significant. So in that way, if you check here, we have noted down all the digits as significant. So there is no insignificant digits over here. Okay, so there is nothing. Okay, now you can see here. These two zeros are again in between the two non-zero digits. So they are also significant. Okay, now what about these two? They are not between the two non-zero digits. So are they significant or not? Right now we don't know because we haven't seen any rule regarding it. So we will see some rule regarding these trailing zeros later on. Okay, then we will find out whether it is significant or not. Right now let's keep it as it is. Okay, let's move on. You can see these two zeros, they are also in between the two non-zero digits. So they are also significant. Okay, you can see this one. This is also in between. So it is again significant. Okay, now over here, yes, this one. This is again between the two non-zero digits. So again it is significant. Now what about this one? So we haven't talked about the rule regarding that leading zero. Okay, see, this is a number less than 1. This is a number less than 1. Okay, and what happens in a number less than 1 we haven't talked about so far. So let's wait and let's see. Okay, till then let's keep it as it is. Okay, let's move on. Okay, over here, is there any zero in between the two non-zero digits? No. So there is no such zero. So right now we'll keep it as it is. Over here, is there any zero? No, there is no such zero. Now over here, yes, over here we have two zeros, right? So these are significant. Okay, now here there is 1, 2. Okay, so these are again in between the two non-zero digits. So they are significant, and we haven't talked about these zeros right now. So let's wait and let's see. Okay, so this is the second rule. First rule is all the non-zero digits are always significant. Second rule says that all the zeros between the two non-zero digits are always significant. Okay, so I hope this is clear. Now let's move to the next rule. Okay, let's see what is the next rule. Third one. Now third rule is about these numbers. Okay, third rule is about these numbers, the numbers which are less than 1. Okay, numbers which are less than 1. So in a number, okay, in a number less than 1, okay, in a number less than 1, the zeros, okay, you can see here, in a number less than 1, the zeros that appear to the right, okay, the zeros that appear to the right of the decimal point, okay, like here, you can see, okay, in a number, okay, in a number less than 1, the zeros that appear to the right of the decimal point and to the left of the first non-zero digit, okay, are always insignificant, non-significant. Okay, in a number less than 1, the zeros that appear to the right of the decimal point and to the left of the first non-zero digit are always non-significant. Okay, so you can see here this number. Over here in this number, these two zeros appear to the right. Okay, appear to the right of the decimal point and to the left of the first non-zero digit. Okay, so these two zeros are non-significant. Okay, so they are going to appear in this column. Okay, so these two are non-significant. Again, what about these and what about these? We haven't talked about. Okay, let's wait. Is there any such number here? No, I don't think there is any number. So this rule applies only to such numbers. Okay, in a number less than 1, the zeros that appear to the right of the decimal point and to the left of the first non-zero digit are always non-significant. Okay, so we have noted this down. Okay, there is no other number like this. Okay, you can take any other example like 0.012. Okay, so here this is non-significant. Okay, so you can understand this. This is not that hard. Okay, now let's talk about the next rule. This rule is about the zeros that appear to the left of the decimal point. Okay, like over here you can see these two. These are the two zeros that appear to the left of the decimal point. Okay, so the rule says that the zeros that appear to the left of the decimal point, okay, zeros that appear to the left of the decimal point are never significant. Okay, they are never significant. Okay, so over here these two zeros that you see in these two numbers, they are not significant. So let's note it down. This zero is not significant. Okay, and over here this one is again not significant. Okay, so in this way we have noted this down, which are the non-significant. Now this one is remaining. Okay, this is the trailing zero. So we haven't talked about trailing zeros yet. Okay, so now the next two rules are about the trailing zeros. Okay, next two rules are about the trailing zeros. Okay, so let's see. So the next rule says that, okay, next rule says that the trailing zeros, okay, the trailing zeros are significant. The trailing zeros are significant if the number has a decimal point. Okay, the trailing zeros are significant if the number has decimal point. So it's very simple. If there is a decimal point, and if such a number has a trailing zero, then it is significant. Okay, then that zero is significant. Okay, so in a number with decimal point, the trailing zeros are significant. Okay, so let's check. Okay, over here you can see there is a decimal point over here, you can check, and there is a trailing zero also. So that is going to be significant, isn't it? So we can note it down over here. It's significant. Look at this. Is there any trailing zero? No, there is no zero. So there is no question. Here there is no decimal point. Here there is a decimal point. Here there is a trailing zero. We have noted it down. Here there is a decimal point, but there is no trailing zero. So there is no trailing significant zero. Okay, no problem with that. Now here there is a decimal point as well as a trailing zero, so it is going to be significant, right? This is going to be significant. Now over here, now there is a problem. Here we have trailing zeros but no decimal point. So right now we cannot do anything with it because we haven't talked about any rule regarding such numbers, such zeros. Okay, so let's wait. Okay, right now let's keep it as it is. Over here, yeah, here we have a decimal as well as a trailing zero, right? So that means this is a significant one. Okay, here it is significant. Okay, so I think in this way we can see there are 3 zeros which are significant. 6-1 is significant. So we have noted down all the digits. So there is no non-significant digit. Okay, there is no non-significant digit. Okay, at the same time, is there any? Yeah, I think this one is also done. 1 2 3 4. Okay, here also this is done. There is no non-significant digit over here. Yeah, and anything else? Yes, I think this is done. Okay, now we have to find out these remaining columns. Okay, and we have to still find out some significant digits, if any, in these numbers. Okay, now the next rule. Okay, next rule is about such numbers where there are trailing zeros but no decimal point. Okay, so the rule is very simple. In a number with no decimal point, okay, in a number with no decimal point, the trailing zeros are never significant. Okay, the trailing zeros are never significant. Okay, in the previous rule we said that in a number with decimal point, okay, in a number with decimal point, the trailing zeros are significant. Over here we are saying that in a number without decimal point, the trailing zeros are never significant. Okay, so just see the difference. If there is a decimal point, okay, if there is a decimal point, the trailing zeros are significant. If there is no decimal point, the trailing zeros are not significant. Okay, so let's look at this starting from this. Okay, so there is a decimal point, so this rule does not apply. Here there is no decimal point, and here we have some trailing zeros also, so they are non-significant. Okay, so over here these two zeros are non-significant. Okay, now over here the rule does not apply because there is a decimal point. Here also we have a decimal point, so rule does not apply. Here also decimal point does not apply. Over here there is no decimal point and we have trailing zeros also, so these three trailing zeros are non-significant. Okay, according to the rule. So 1, 2, 3, these are non-significant digits. Okay, yeah, so here again we have decimal point, so this rule does not apply. Now here there is no decimal, at the same time we have a trailing zero also, so this is a non-significant digit. Okay, so in this way we can see that we have found out the significant as well as non-significant digits in these given numbers. Okay, these are just random numbers I have taken as an example. Okay, in your book also you will find out lots of these. Okay, and in your questions also you will find out. Okay, but you just have to apply these rules over here, that's it. You just have to apply these rules over here and that's very simple. Okay, you can easily find this out. Okay, so these are the rules. Okay, so I will just revise all these rules. First rule says that all the non-zero digits, okay, all the non-zero digits are always significant. Second rule says that all the zeros between two non-zero digits are always significant. Okay, third rule says that, okay, third rule says that in a number less than 1, okay, in a number less than 1, the zeros that appear to the right of the decimal point but left of the first non-zero digit. Okay, right of the decimal point and left of the first decimal point, like yeah, over here. Okay, these zeros which are appearing to the right of the decimal point and left of the first non-zero digit. Okay, so such zeros are not significant, so that is the rule. Okay, the next one is the zeros that appear to the left of the decimal point, they are not significant. Okay, they are not significant. Okay, next rule says that in a number with decimal point, in a number with decimal point, the trailing zeros are always significant. Okay, the trailing zeros are always significant, like this one. In a number with decimal point, the trailing zeros are significant. You know why this is significant? Because this zero talks about the precision of the instrument. Okay, this zero says that the number has been measured up to this much resolution. Okay, this number has been measured up to this much resolution. Okay, this is precision. Okay, this talks about the precision. That's why it is significant. At the beginning itself, I said that significant figures talk about the precision of the instrument. If any digit talks about the precision of the instrument, then it is considered to be significant. Okay, that is what we have applied over here. Next rule says that in a number without decimal point, like this one, okay, number without decimal point, the trailing zeros are never significant. They are never significant. Okay, because these guys don't talk about the precision actually. Okay, because there are other ways actually. There are other ways in which it can be represented. The same number can be represented in other way also. That's why these three digits are not considered as significant. Okay, these are not, because this 5, only this number, this digit is able to talk. Okay, is able to give us the information about the measured quantity. Okay, about the measured quantity if we represent this whole number in a scientific way. Okay, I will tell you what is that. Okay, but this is the rule. Okay, in a number without decimal point, the trailing zeros are never significant. Okay, so these are the some of the rules to find out the significant figures. Okay, so I hope this is very clear. Now there is only one problem. Okay, there is only one problem that is related to these trailing zeros. We have seen that there are two different rules for trailing zeros. One for those numbers having decimal point, one for those numbers having no decimal point. Okay, so there is a little bit of ambiguity. Okay, there is a little bit of a confusion. Okay, how to do it, where to do it, how exactly to go about this. So for that there is a way actually. There is a way. Okay, what we do is generally, okay, we generally represent all the numbers in a scientific form. Okay, in a scientific form. Okay, to remove such confusion, we represent all the measured quantity in a scientific form. Now you will ask, what is the scientific form? So scientific form is something like this: A into 10 raised to B. Okay, so we represent any number in the powers of 10. Okay, in the form of powers of 10. This is how we represent any number. For example, this one. This is 5,000. Okay, this is 5,000. So how we will represent this 5,000? It's very simple. We can write this as 5 into 10 raised to 3. Or first of all, 5 into 1000. That is 5,000. Okay, so 5 into 1000 is 10 raised to 3. So you can see here, this number has been represented in the form 5 into 10 raised to 3. So this is called as scientific way or scientific form of writing any measured quantity. Okay, so you can see here, this form and this form matches. Okay, writing in the power of 10. Okay, so if you compare these, so A will be equal to 5 and B will be equal to 3 in this case. Okay, A will be equal to 5 and B will be equal to 3 in this case. Okay, so this is the way generally we represent any value. Why? I will tell you. Okay, why do we really do this? There is a reason for that. See, suppose you make some measurement. Let's say you have made some measurement. Okay, let's say for example length. Let's say the length is somewhat like, let's say 155 meters. For example, let's say the length is 155 meters. Okay, so this 155 meter can also be written in other way. We can write it in centimeters. So 155 meters converted to centimeter gives us what? 0 centimeter, right? You can see, okay, 15500, because we know 1 meter is 100 centimeter, right? So that is what we have done here, multiplied by 100. And we can also convert this to mm. Now in mm it would be 155,000 mm, millimeter. Okay, millimeter. Now when you write it like this, okay, now when you write it like this, the number of significant figures do not change. Remember this. Okay, you choose any unit. Okay, you choose any unit. It does not matter. The number of significant figures should not change. Okay, should not change. That is why if I only consider this one, this has 3 significant digits. You can see 1, 2, 3. This has only 3 significant figures. Okay, if I go here, this number also has 3 significant figures. Okay, because these two are the trailing zero, these 3 are the trailing zeros, and we have just seen the rule. Okay, in a number with no decimal point, the trailing zeros are not significant. Okay, over here, and same here also we have 3 significant figures. Okay, 3 significant digits. Okay, so now you may say here, no, here there are 6. No, there is other way of writing this. Okay, we can write this as 155 into 10 raised to 3 mm. We can write this in this fashion also, right? Because these 3 zeros can be written as 10 raised to 3. Okay, now this 10 raised to 3 talks about these 3 zeros. That's it. And 155, this 155, these 3 digits talk about the information hidden in this number. Okay, because that is what we want. Okay, significant figures are what? Significant figures are those digits which actually give us information hidden in the number. Okay, information is what? Like the magnitude. First thing is magnitude of that physical quantity, and then second is the precision to which it is measured. So over here there is no precision mentioned because there is no decimal point. Okay, precision comes when there is a decimal point included, but there is no decimal point, so there is no question of precision. But over here there is a problem of magnitude. So this 155 can talk about the magnitude, right? And this 3 zeros can be represented by this 10 raised to 3. That is the reason why these 3 zeros are considered to be non-significant, because they are irrelevant. They are irrelevant when we talk about the information. Okay, because these 3 zeros are not that much required to represent or to talk about the information hidden in the number, because these can be written like this, 10 raised to 3, that's it, in the powers of 10. So all the information is conveyed by this number 155. This talks about the magnitude. Okay, and this 10 raised to 3, okay, it talks about what is the order. Okay, this 10 raised to 3 is called as the order. Okay, so that is the reason why these 3 are considered to be non-significant. Same here, these 2 are non-significant because they are irrelevant to the information. Okay, these 2 talk about the magnitude, so they are relevant. Over here you can see there is no zeros. Over here there are no zeros. Okay, so these 3 digits, they talk about all the information hidden in the number. Okay, so that is why these 3 are significant. Okay, so over here there is one rule that you can make out from this, that is even if you change the unit of any number, any measured quantity, still the number of significant figures does not change. They do not change at all. Okay, so the choice of unit does not change the number of significant figures. Whichever choice you make as a unit, okay, centimeter, mm, meter, whatever, the number of significant figures remain same. Okay, remember this. Okay, So generally what we do is, generally we represent any number, in the scientific form. It is not only applicable to such numbers, it is applicable to numbers with a decimal point also, like these number. For example, look at this number. If I talk about this number, this is 0.00230. okay, now over here there are three significant figures. Just now we have seen there are three significant figures. Okay, so we can write this number as, okay, see what I can do is I can just shift the decimal point 1 2 3. Okay, so if I shift this, it would be 2.30 into 10 raised to minus 3. Okay, into 10 raised to minus 3. Okay, because we are shifting it forward. Here you can see in this case, in this case 5000, we are shifting it backward. Okay, here that's why it is plus 3, and here we are shifting it forward, so it is minus 3. Okay, so I know this, you know this already. Okay, so you can see here how we have represented this. Okay, this number in the power of 10, and we have represented in such a way that the precision is not lost. You can see this number still talks about the precision. I could have easily removed this 0. You know, let's say, let's go, let it be, what happens? Okay, because anyways 2.3 and 2.30 is having the same values, isn't it? Even if I multiply, add, you are going to get the same number, isn't it? So you might just say, why to write that 0? No, you can't do that. This is the 0 given by the instrument. It talks about the precision, so you can't remove it. Okay, it's all about the information, it's all about the precision. You can't remove it. Okay, you can't remove it until and unless some other rule comes in. I mean, when you go for some other mathematical operations, okay, which we will see actually how exactly to do that. Okay, so in some mathematical operations, these significant figures may just be dropped off. Okay, but how exactly, there is a rule for that also. Okay, so generally we write any number in the powers of 10, which makes it easier for us to understand. It makes it easier for us to find out the number of significant figures. Okay, you can see here also we have maintained the number of significant figures. Here also we have maintained the number of significant figures. See, in this 5000 there was only one significant figure. Look at this. Okay, only one significant figure. Okay, so this is what we generally do. Okay, so this b that you see here, this power of 10, this b, okay, this b is called as order of magnitude. Okay, this is called as order of magnitude. Okay, remember this. This b can be positive as well as negative, just like we have seen here. This is plus 3, this is minus 3. It may be of any value. It's not only plus 3 or minus 3, it can be of any value. Okay, so this b is called as order of magnitude. It's a very important number. Okay, it's a very important number. Okay, so these are some rules. Now we move to the last rule. Okay, to find out the significant figures. Not to find out actually, but actually if you say this is a rule that you should use to do some mathematical operations actually. Okay, this rule is quite important while doing some mathematical operations. Okay, so let's see what is this rule. Okay, now you know, when we do some mathematical operations with our measured quantities, okay, when we do some mathematical operations with our measured quantities, we generally encounter with some constant number or some exact numbers. Okay, we generally encounter with some exact numbers. Okay, exact numbers are what? You know, those numbers which are neither rounded off nor some measured value. What I mean is, they are neither some measured value nor some rounded off number. Okay, what I mean by this, I will tell you. For example, circumference, formula for circumference is 2 pi r. Okay, look at this 2. This 2 is neither a measured value, right, nor some rounded off number. Okay, it comes in the formula actually. Okay, because of some reasons that you know why it comes there. Okay, so this number is called as a exact number, or we can say yes, diameter. Diameter is 2 times radius. So this 2 is an exact number because it is not a measured quantity. It is also not a rounded off number. Okay, so it's an exact number. So now the rule is regarding this exact number. Okay, now the rule says that the exact numbers, okay, the exact numbers have infinite number of significant figures. Okay, the exact numbers have infinite number of significant figures. Okay, any exact number. It's not just this 2. Whatever you see, sometimes you will see 4. Okay, so in any formula, if you see any exact number, that exact number has infinite number of significant figures. Infinite means what? Something that is not finite. We don't know the number. Okay, something that is not finite. Now you might ask why. Yes, there is a reason for that also. So let's understand what is the reason behind this. Okay, why do we do this? Why do we consider infinite significant figures? Okay, for this exact number. Okay, it's very simple. For example, if I talk about this radius and the diameter, for example, if I talk about the radius and the diameter, then suppose I have measured the radius. Okay, let's say we have a measured value of this radius. Okay, let's say with the help of some vernier caliper, let's say, okay, with the help of vernier caliper, we have measured the radius, and the radius is about, let's say it is 2.49, for example, okay, centimeter. Let's say this is the radius. Okay, this is the radius. Now how would you find out the diameter? It's 2 times radius, right? So radius is 2.49 centimeter. Okay, so diameter would be what? What would be diameter? Over here, 2 into 49, 2.49 into 2. So what that would be? 2.49 plus 2.49, right? Twice. Okay, so what it would be? It would be, I think, yeah, it is 4.98, barabar, right? This would be 4.98. Okay, that should be actual. Now actually there is a rule. Okay, there is a rule for this multiplication also. Okay, when you multiply two numbers, okay, having different number of significant figures, okay, you can see here there is only one digit, here there are 3 digits and all 3 are significant. So if I consider, for example, see, this 2 is exact number. Just now we have said this 2 is an exact number. And right now, if I consider that it has only one significant figures, for example, okay, exact number, according to the rule, the exact number has infinite number of significant figures. But let's say we have a finite number, that is one significant figure. Okay, now the rule says that when you multiply two numbers with different number of significant figures, then the result of this operation must retain as many number of significant figures as there are in the number with least number of significant figures. Okay, what is the rule? When you multiply two numbers with different number of significant figures, then the result of the operation should retain as many number of significant figures as there are in a number with least number of significant figures. So which is the number with the least number of significant figures? This one. How many are there? Only one. Okay. So your result must also possess only one significant figure. Okay. So the answer over here should have only one significant figure. So the answer is this. Answer is this. So in that case, what would be your answer? Your answer would be, you might say 1. Okay, I mean 1 digit, 4. But is that the right answer? No, that is not the right answer. Isn't it? We want the accurate answer, isn't it? Even if I say this 4.98 is rounded off to 5, still it is not the right number. Okay, still it is not the accurate number. Still it does not talk about the precision with which the radius was measured. Okay, this 4 or this 5, whatever you take, still it does not talk about the precision. Okay, so how can it be right? Okay, so what to do now? What to do now? The rule suggests that there should be only one digit. So that is the reason. What we do is we consider the exact number to be having infinite number of significant figures. So we can write this exact number as, how we can write this as, we can write this as 2.0, 2.00, 2.000, okay, or you can just increase the zeros. Now how many zeros to be kept over here? That depends on the situation. Like here we have 3 significant figures. So what we do is we choose this number instead of this. Okay, because this 2.00 has 3 significant figures. You know, according to this rule, a number with a decimal point, the trailing 0 are significant. So same here, this we have considered this as a number with a decimal point having 2 trailing zeros. So it is now having 3. So now we have both of these numbers, like this 2.00 and this 2.49, both have same number of significant figures. Now there is no issue. Now you can get your right answer, that is 4.98. Okay, so that is the reason why we choose this exact number to have infinite number of significant figures. See, infinite, sometimes people think that infinite means very large number. Okay, but over here we don't mean a very large number. We mean here that it's not finite, it's not fixed. Okay, its value, I mean the number of significant figures in exact numbers like 2, okay, they change according to the situation. We just check here what we are multiplying with. Okay, we just check here what we are multiplying with. That's it. Okay, or maybe if you are adding, we will check how many decimal places are there in the other number, according to which we will change this number. We will increase the number of significant figures. Okay, so that is what we mean here. Okay, when we say infinite significant figures. Okay, so these are some rules actually to represent, okay, or to find out the significant figures, okay, in any number. Okay, so I hope these are clear. Okay, these rules are very, very clear to all of you. Okay, so especially this last one is also very important. Okay, but generally questions may not be asked on this. I mean, it can be, who knows, but mostly it will be asked on this. You know, such numbers are given to you generally in exams, and they will tell you to find out how many number of significant figures are there. Okay, that can be told, or there are other questions also that are based on the next video actually. Okay, in the next video we are going to see how to write the significant figures. Okay, how to write the significant figures after mathematical operation. Okay, suppose we are adding 2 numbers, multiplying 2 numbers, dividing, then how many number of digits to be retained in the result. Okay, so that thing we will see in the next video. Okay, so I hope everything is clear so far. Okay, I hope you understood the rules for determining the significant figures. Okay, all these. Okay, this one. Okay, so I will stop over here for now. I will see you in the next video. Okay, so till then, see you. Bye bye. Have a nice day.